At precisely 6:04 p.m. yesterday, a tweet was posted. India, I reached my destination and you too. A message from ISRO confirming the landing of Chandrayaan-3 on the moon. A momentous event that united the entire nation of 1.4 billion people who cheered, jumped, and danced in joy and pride as India scripted history by being the first nation to land on the south pole of the moon. Respected founders, principals, coordinators, members of the school management, and our beloved students. Wish you a very good afternoon and welcome to the panel discussion today titled ISRO's Lofty Leap, a scholarly symposium, where our young minds will share their thoughts on the past, present, and future of the mission. I, Sangeeta Basu from the NIOS School, along with Ms. Lisha Shaha from British High School, will be the moderators of the session. Over to you, Ms. Lisha.
Scientists believe that South Pole of Moon could hold vital reserves of frozen water and precious elements. And by landing a spacecraft on this uncharted territory of Moon, India as a country cements its growing prowess in space and technology. Good afternoon, everyone, and I welcome you all in today's program. On the panel, we have our very talented and erudite students who are going to shed more light on the topic and share their thoughts on the mission. So without taking much time of yours, let us get introduced to our panelists. Starting from our youngest one, from grade 6AA, we have Nivan Gupta. From grade 7MA, we have Vikrant Vivekanand Prabhu. From 8MB, grade 8MB, we have Himesh. From grade 8, we have Bhavadipti and Shriyant Srinivas. From grade AA, we have Shriyant Srinivas. And from grade 9, we have Ditya. From grade 10, we have Enam and Casey. And from grade 11, we have Shobhit Malakar. Over to you, Ms. Sangeeta.
Thank you, Ms. Lisha. By the gleaming looks on everyone's face, I can tell how excited the participants are. Would you like to share your feelings about the memorable success? Yes, Shobhit.
Good afternoon, everyone. I'm happy to be sharing my feelings of ISRO's spectacular achievement yesterday. As I was seeing the lander land on the moon, my heart was filled with joy and I was deeply proud. So, yeah.
Absolutely. Anyone else would like to share their feeling? All right. Let's begin by taking a brief sneak peek in the past and explore. When did it all begin? The thought or dream to have a lunar mission in India? The question is open to you, panelists. Yes, Shriyant?
Thank you, ma'am. And hello, everyone. I believe the dream of having a lunar mission began with the establishment of the Indian Space Research Organization in 1969. The first lunar mission, Chandrayaan-1, was launched by ISRO on October 22nd, 2008.
Okay. Vikrant?
Hello, everyone. When did it all begin, the thought or dream to have a lunar mission? I believe the idea of a lunar mission was first thought of in 1999 during a meeting of the Indian Academy of Sciences, and the Astronautical Society of India carried forward the idea in the year 2000.
Over to you, Bhavadipti.
Yeah. Hello, everyone. So I believe India drew inspiration from nations like Japan, Russia, and the US, igniting a desire to partake in the lunar exploration endeavor. This aspiration led to the conception of their own lunar mission. With that, Chandrayaan-1 was built and launched on October 22, 2008 successfully.
Thank you for the information. Yes, Casey?
Good afternoon to all. So I think the interest of lunar exploration specifically gained momentum in the late 2000s, and the dream of lunar exploration for India was because of their curiosity. And while they were curious to know what our celestial neighbor, the moon, had for us, and technological advancements were taking place. And I think it started driving an aspiration to mark a space exploration. And we witnessed Chandrayaan 1 and 2 to be the outcomes of these dreams.
Wow. Over to you, Ditya.
Good afternoon, everyone. I would say everything began on 15th August 2003, when Prime Minister Atal Bihari Vajpayee announced the Chandrayaan project in his Independence Day speech. The mission was a major boost to India's space program. The idea of an Indian scientific mission to the moon was first mooted in 1999 during a meeting of the Indian Academy of Sciences. The Astronautical Society of India carried forward the idea in 2000.
Thank you so much, Ditya. Over to you, Ms. Lisha, for the next question.
What an insightful answers these panelists have given us. Thank you so much. Continuing with our exploration of Chandrayaan's past, it is said that Chandrayaan 3 is a successor to Chandrayaan 1 and 2. So our second question would be, what were the main objectives of the first two missions, Chandrayaan 1 and 2?
Yes,
Okay,
Dinesh?
Shreyan, we would start from you.
Yes.
Thank you, ma'am. I believe that the last two lunar missions were Chandrayaan 1 and Chandrayaan 2 by the Indian Space Research Organization. Chandrayaan 1 was launched in 2008 and had the following objectives. First was, it aimed to find frozen water deposits in the moon's polar regions. The spacecraft carried 11 scientific instruments built in India, the USA, the UK, Germany, Sweden, and Bulgaria for chemical considerations. Although communication with the spacecraft was lost in 2009, it achieved 95% of its objectives. Chandrayaan 2, launched in 2019, had these objectives. First, the mission included scientific studies by payloads on both the orbiter and the technology demonstration of soft landing and roving on the lunar surface. Most of the components of technology demonstration, including the launch, orbital critical maneuvers, lander separation, and deboost and rough braking phase, was successfully accomplished. However, the lander failed to make a soft landing though. Despite this, all 8 scientific instruments of the orbiter are performing as per design and providing valuable scientific data.
Great. Shreyant, I really appreciate your detailed answer. Inam, would you like to add something to this? Inam?
No, not really. He already said what I was planning.
All right. We have some really good raised hands. Nivan, what about you, my dear?
Hello, good afternoon, everyone. So I would also like to add that the orbiter in Chandrayaan 2 had actually helped support Chandrayaan 3, is propulsion and lander module in communicating as well. So it was very helpful over there as well.
Great. Over to Ditya.
Talking about Chandrayaan 1, Chandrayaan 1's objectives were extensive mapping and analysis of the lunar surface, shedding light on the lunar surface's chemical composition, mineral distribution, and geological features, and all the planned objectives were achieved. These findings contributed to a deeper understanding of the moon's origin, evolution, and its relationship with Earth. Now, when we talk about Chandrayaan 2, the primary objectives of Chandrayaan 2 lander were to demonstrate the ability to soft land and operate a robotic rover on the lunar surface. While the soft land did not go accordingly, the others were achieved. And the other scientific objectives of the orbiter were to study lunar topography, mineralogy, elemental abundance, and the lunar exosphere and the signatures of hydroxyl and water ice.
Great. Thank you, Ditya. Bhavdipti?
Yes, thank you, ma'am. So the objectives of India's Chandrayaan-1 lunar mission were to map the moon's surface, study its mineral composition, investigate the presence of water ice, and conduct high-resolution remote sensing. The objectives of India's Chandrayaan-2 lunar mission were to explore the moon's south polar region, study its surface and mineral composition, search for water ice, and demonstrate soft landing technology through a lander and a rover, but it was not successful.
Wonderful. Mineralogy, topography, and all the aspects related to the elements of various elements of moon. Wonderful. Thank you so much. Over to you, Ms. Sangeeta.
Thank you, Miss. Himesh, you raised your hand to comment on this. Would you like to add something?
Yeah, it also conducted mapping analysis to discover what are the poles of the moon and to discover the materials that are present. So when the asteroids clash each other, they might create some fusion, which can be resourced and be used more.
That is wonderful. So can we say that the past missions, they were actually gathering data through all senses, right? Okay. So my next question will be, the first lunar mission made a remarkable discovery, the presence of water on moon. While the second mission was unsuccessful, but we are not entirely be going with this term completely unsuccessful. There were definitely some takeaways. What were our objectives this time? What have we learned from the past missions and have carried forward in this one? Yes, Himesh?
Chandrayaan-3 is a follow-up mission on Chandrayaan-2. Its objective is to demonstrate a safe and soft landing on the lunar surface, roving on the moon, and to conduct in-place science experiments about the moon to discover more chemical composition, mineral distribution, and many other things with the help of Pragyan rover and with the Vikram lander.
Thank you for the information. Yes, we are looking for chemical resources and mineral resources there. Over to you, Vikrant.
Objectives for Chandrayaan-3 were actually almost the same as the last mission, albeit with a few changes, such as getting a lander to land safely and softly on the surface of the moon, observing and demonstrating the rover's driving capabilities on the moon, and conducting and observing experiments on the materials available on the lunar surface to better understand the composition of the moon.
Thank you. We want to learn the composition of the moon itself and see if there is something we haven't learned yet. Yes, over to you, Bhavaditi.
Yes, thank you, ma'am. The mission objectives of Chandrayaan-3 were to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and to conduct in situ scientific experiments.
Exactly. Something that we have learned from the past mission and applying it. Let's hear it from Inam.
I'd like to add on to all of these points by also mentioning that to make achieving these objectives easier, they've also used the already existing infrastructure, such as the orbiter from Chandrayaan-2, which is already orbiting the moon. And hence they've cut down a lot of costs, so they allowed it to focus on the rover more. And hence the rover has a lot of new payloads to help conduct the scientific experiments more clearly.
Yes, reusing what we already had and cost cutting, of course. Let's hear it from Shriyant.
Thank you, ma'am. And there were great points from our fellow panelists, and I would like to add on the thought of this mission. The thought of Chandrayaan-3 was, if it was successful, it will be the India's first successful landing of equipment on the lunar surface.
Exactly. What an achievement it was. Over to you, Nivan.
Yes, thank you, Miss. So I would also like to add that the success of Chandrayaan-3 established possibilities for long-term goals as well. Since the the missions kind of had a united objective to find more prevalent in deposits of water on the moon, we can actually use that to our advantage by building lunar bases where people could actually establish permanent settlements. And also, the water rights could not only just provide drinking water to our pioneers, but could also be used as fuel, as the oxygen in water is a really reactive substance.
That's such a wonderful thought, actually. Who knows, someday we can actually be on the moon, right? So this time we have sent a machine, but who knows, next step will be probably sending a person to the moon. Would anybody else like to add? Or we can move to the next question. Over to you, Ms. Nisha.
Thank you, Ms. Sangeeta. I'm totally amazed with the kind of answers
Aren't we?
they are coming
Yes.
up. Yes. Coming to our next aspect, there have been many roadblocks to all the space missions that India has executed, especially in terms of budget and use of technology. That brings us to our next question. What challenges and complexities are associated with planning and executing lunar missions like Chandrayaan, especially after the last mission, and how has ISRO overcome them? Shobhit.
Thank you for the question, ma'am. So to begin, there are numerous challenges faced by space agencies when planning for lunar missions, like communication. Ensuring constant and reliable communication with Earth, especially when the moon is on the far side and out of the direct line of sight. Second point, sample collection. Collecting lunar samples and ensuring their safe return to Earth. And the third one, budgeting and funding. Securing the necessary funding and managing the budget for a lunar mission is a significant challenge. After what happened to Chandrayaan-2, ISRO successfully overcame challenges like the first point, data analysis and review. Following the Chandrayaan-2 mission, ISRO conducted a thorough analysis of what went wrong during the descent and landing phase, where the Vikram lander lost communication and crash landed. So this involved reviewing telemetry data and conducting simulations to understand the issue and rectify it in Chandrayaan-3. The second point, enhanced communication. ISRO may have improved communication systems and redundancy to ensure better connectivity with the lander and rover during critical phases of the mission and ensuring success of the mission. Thank you.
Really appreciate your meticulous answer, Shobhit, and how nicely you've put it in the form of points. Moving forward to Vikrant.
Thank you. I would like to add to Shobhit's point about budgeting and about budgeting. ISRO has overcome the budget problem by cutting unnecessary corners, like saving fuel every perigee, which is the point in the orbit of a moon or a satellite at which is nearest to Earth. Separating the payload plan into different missions like the rover, lander, and orbiter separately, and minimizing the size of the payload while adding extra measures to stabilize the rocket. In fact, Chandrayaan-3 actually was created on a very small budget that was actually less expensive than the movie Interstellar.
What a fact that you have brought in, Vikrant. Thank you. Himesh.
ISRO launched its second attempt to land at the moon, aiming to become the fourth country to achieve this feat. The mission faces challenges such as navigating the long journey, entering the moon's orbit, and mainly moving the vehicle from horizontal to vertical orbit. ISRO has overcome them by putting a lot of effort in making surveys, discovering, reusing, and saving resources.
The thorough survey and thorough research after meeting that unsuccess, or we can say a setback that has really set ISRO on this journey of success. Vidya?
Yes, ma'am. I'd like to add a few more points on where our missions could go wrong and where we mainly face our problems. So despite the fact that humans first landed on the moon more than 50 years ago, the task is still quite difficult. Long before you can even think of landing on the moon, you will have to figure out how to get there. On an average, the moon is about 3,84,400 kilometers away from our planet, and depending on the path taken by the spacecraft, that distance can be much higher. A failure can occur anywhere on this long, long journey. Needless to say, there is no GPS on the moon. Spacecrafts cannot rely on a network of satellites to precisely land at a particular location because that simply does not exist on the moon. This means that onboard computers will have to make quick calculations and decisions to land itself precisely on the moon. This becomes especially complicated when a spacecraft gets within the crucial last few kilometers, according to a report in the journal Nature. At that point, the computers on board will have to autonomously react quickly to last-minute issues. For example, sensors could become confused by the large amounts of dust kicked up by the propulsion systems. And these were the same landing complications that our Chandrayaan-2 faced. But actually, the Chandrayaan-2, our research scientists prepared Chandrayaan-2 in such a way that the mission could fail, but still be a success. That is, the landing could fail, but all of the other objectives and the rovers, they could all be a success, and we could achieve the scientific discoveries we intended to.
Yes, true. Agree with that. Casey?
I think the points actually really well put by others, and the same that's what I wanted to add on. But I think the complexities that the craft actually faced, temperature fluctuations, solar winds, controlling the velocity in the last few descent phases, controlling the soft landing, it was definitely tedious, I think, for ISRO. And I think just to after they went through that data analysis, and I think they understood what they had to correct, and they brought in altimeters, velocimeters, initial measurements, and so many things that they brought up. And certainly it was never easy for them. And I think surely Chandrayaan-2 was a big learning for them, for ISRO especially, and we have successfully completed the mission.
Absolutely, truly agree with this. And now, would you add to this?
To add on to all of this, another thing would be the budget problem. So, for example, Russia's Luna 25, which recently crash landed, which was a failure. It had to achieve the same objective, but because they had a higher funding, around 1,600 crores, compared to Chandrayaan-3, which had a budget of just 600 crores. So overcoming that budget is such a hassle. And to do this, they mainly focused on fuel consumption by using the Earth's orbit as a slingshot. And also another thing would be that they saved a lot of cost by omitting the orbiter, because there's already the existing orbiter from Chandrayaan-2. So they replaced it with the propulsion module, and even the propulsion module has a payload that allows it to orbit the moon while collecting data for exoplanets. So they definitely achieved a lot of efficiency here.
Yes, lots of learning for us from the Chandrayaan-1 and 2 missions, and putting it all together and bringing up a huge success of Chandrayaan-3. Over to you, Ms. Sangeeta.
I think Nivan has raised his hand. Nivan, would you like to add anything to it?
Yes, Miss. Thank you. So I would also like to add that Chandrayaan-2's one of the main reasons why Chandrayaan-2 had failed, at least in the landing phase, it was because they actually chose a very narrow landing site. And there was a lot of room for its firing out of control and maybe going outside to a much more rough surface. And the reason why there's so many problems with this is because that the Chandrayaan missions are landing on this place called the lunar highlands. If you know that. And in the Apollo missions where the moon landings happened, were all on the lunar maria, which are these really smooth surfaces that are often not cratered at all. However, the lunar highlands are much more rough, and there's a much higher chance of failure at landing. So Chandrayaan-3 had actually improved on that by choosing a better landing site and increasing the area of the landing site, which lowered the stakes of the mission and allowed it to be just as successful as it is.
Thank you so much, Nivan, for pointing that out. Yes, there can be so many roadblocks when it comes to expeditions like this, in terms of budget, especially for a country like ours, and technological advances also, and choosing a proper site. Yes, these little details, they do matter. We always look at the bigger picture. Once it is shown on the television, we're all cheering. But it's the hard work of the scientists, and it did not happen in a month or a year. It took years of continuous learning and applying them, right? Thank you so much for sharing all your thoughts. Now, moving to the next question, we are in the age of Make in India, where we are trying to promote things that are made, designed, and executed in our own country. So what role does indigenous technological development play in ISRO's success? And how has it contributed to the innovation behind Chandrayaan missions? Shobit.
Thank you, ma'am. So to answer this question, if you look at the question from Chandrayaan's point of view, indigenous technology development has been instrumental in creating the spacecraft lander, rover, and scientific instruments. ISRO's ability to design and build spacecraft, develop propulsion systems, create communication networks, and fabricate scientific instruments in-house has been vital for the success of Chandrayaan 1, 2, and now the Chandrayaan 3. So these missions have expanded our understanding of the moon, provided valuable data for scientific research, and demonstrated India's capabilities in deep space exploration, all of which were made possible through the innovative use of indigenous technology and has played a significant role in cost efficiency for ISRO.
Yes, Shobit. If you have watched the video where the ISRO scientists, they are shown to literally create everything from scratch, joining little bits and pieces of parts to make that huge rocket that will be launching the Chandrayaan, and also how many experiments, how many simulations they have gone through before they could finalize the design. Let's hear it from Shriyant.
Thank you, ma'am. So, indigenous technology development has played a crucial role in ISRO's success. It has enabled ISRO to overcome international restrictions and develop self-reliance in critical technologies. Here are some ways it has contributed. Firstly, indigenous amplifier. In the Chandrayaan 3 mission, an indigenous 5-watt signal amplifier played a crucial communication role. This amplifier was instrumental in getting the message from the lander and rover to the satellite orbiting on the moon's surface. Second, hazard detection and avoidance system. ISRO introduced an indigenous hazard detection and avoidance processing system in the Chandrayaan 3's mission. Third, laser Doppler velocity sensor. This is which discharges laser pulses towards the lunar terrain, which used in the Chandrayaan 3 mission by gauging the alterations in the reflected waves. The craft's instantaneous velocity is reduced. Reusable rocket technology. ISRO has also developed reusable rocket technology, which is a significant step towards reducing the cost of access to space.
Wonderful points put forward, Shriyant. Let's hear what Nivan has to say.
Okay, so thank you, Miss. I would also want to talk about some budgetary concerns of ISRO. So by making their own indigenous technology, it's also possible that they can greatly lower their prices for each of these materials that they use, and they can apply their own methods to make sure that their budget is in check and that they can focus their money on other areas, and to make sure that their entire mission plan is most effective. And I would also say that making indigenous technology and getting a win from it is actually a really good sign for investors who are looking forward to seeing India grow. And it really gives some light on how our country can really prosper if they can continue to make in India.
Yes, Nivan, you brought forward a very important point that, yes, this time investors, national investors, they were also interested in investing in such expeditions so that the budget can be shared and we don't stop anywhere. Yes.
Thank you, ma'am. Having our own parts from our own country not only means that we don't need to import parts and that we can customize our parts to our specific needs, but we can also rely on our own parts more since it's made in India, giving the people of India a sort of role model to look up in the sense of their country's pride. This process is also giving us an excellent reputation around the world, as many companies are also starting to produce their parts in India instead of China. Also, this process has ISRO, like with the introduction of a hazard detection and avoidance processing system, a technological marvel that helped with the successful landing.
Yes, Vikrant, thank you so much for your information. And I think the way the panel discussion is going on, we wouldn't like to stop it anywhere or end it anywhere. We can just go on listening to you all. You are so well researched. Thank you so much for your responses. Over to you, Ms. Lisha, for the next question.
I totally second you, Ms. Melissa,
Absolutely.
related to how well informed and such thorough research they have done. Moving on to next, we have talked so much about the successes and the main objectives of Chandrayaan mission. Coming to our next aspect for discussion, what do you think are the long-term benefits of the lunar mission? Okay, I'll start with Vidya.
Thank you, ma'am. Well, now that Chandrayaan-3 was successful and India became the first country to land approximately on the moon's south pole, we are going to get a lot of recognition geologically. And now other countries would be interested in collaborating with us. We might have investors who would be interested in investing on our space services. Space-related job opportunities might increase. Not just this, we'll also find out a lot of information about the moon, and with this knowledge, we can of course start new researches and basically just learn a lot on the moon. We can unlock the secrets of the universe and especially the moon. And I'd like to add that we once again break away the superstitions about the moon and let science guide the way for us.
Wonderful. Yes, opening up the new eras for many of us, different jobs which will be created. Wonderful. Agree with this totally. Moving on to next, Nivan.
I would also like to add that there is a lot of benefits that can support India and other nations back on Earth. You see, there is a lot of rare earth minerals that are really invaluable on Earth and can take millions just for some kilograms. However, thanks to missions like Chandrayaan-3, who are graciously exploring the surface composition of the moon, we might be able to find out that there are a lot of rare earth minerals that are not that rare on the moon. And we can soon later transport them back to Earth to increase a lot of treatment facilities and production and in mass industrialization, as well as going for more eco-friendly ways to power ourselves.
It's an innovative idea that you have shared over here, bringing in the the rare earth. Yes, thank you so much, Vikrant.
Thank you, ma'am. The long-term benefits to lunar missions are that we are not only expanding our knowledge about space and inspiring many people, but we are also making a name or recognition for ourselves, which means we will have even more opportunities.
Wonderful, that's true. Shobhit.
Thank you, ma'am. Whatever the fellow panelists told was bang on correct. But another point I would like to add is moon could help us as a stepping stone. How? Like establishing a sustained human presence on the moon can serve us as a stepping stone for future missions like to Mars and even beyond. So enabling humanity to explore and colonize other parts of the solar system as well.
Absolutely true. Himesh?
Thank you. Lunar missions provide a valuable scientific research opportunities, including the study of geological process and the potential life on other planets. They also stimulate technological advancements and inspirations for other people and future generations to pursue a career in STEM.
True. Priyank.
Now, I would like to add on some points. First of all, infrastructure development. Establishing a permanent base on the moon can facilitate human missions to Mars. Launching from the moon is more efficient than launching from Earth due to the lower gravity. And the source utilization. Lunar missions can lead to the extraction of lunar resources, which requires a long term permanent presence. And commercial opportunities, which are lunar missions can open up opportunities for commercializing the moon and advocating for a lunar and cislunar infrastructure, economy, and settled society.
Long-term benefits of these lunar missions are so well put up by all of you. We have a lot of wonderful audience over here with us, around 1,100 people. Really appreciate the presence of all of you. And one small question for the audience also over here. We've looked into the past, we've looked into the present, and we are also discussing about the future. For audience, why do you think this Chandrayaan 3 is important? You can share your ideas in the chat. Chandrayaan 3, so many aspects we talked about. We talked about its main objectives. We talked about how Indian scientists have worked their ways to make this a huge success. So why do you think this Chandrayaan 3 is important? What importance rather it holds? Come on, audience. Okay, I'll do that. I have yes.
The question is open to the audience.
Yes, we're getting answers. India's third lunar mission called Chandrayaan 3 made India the first country to successfully land near the moon's south pole, a region that has picked the interest of scientists due to its unique characteristics. That's very well done. Yes, that's true. It indeed has put in India in the first position, rather to soft land on this rather challenging terrain, where the countries like US, Russia, and China, they have done the soft landing, but not on this particular terrain. That's true.
Exactly. So on that note, I will be asking the next question. So yesterday when I was watching the news, it flashed, India has now entered the elite club of countries which have landed on moon. But here I would like to add something. Probably we have created a new club, that the country which has landed on the South Pole, we are the first one. So my question will be, how has the success of Chandrayaan missions so far contributed to India's geopolitical position in the global space community and its collaborations with other countries? Himesh, we'll begin with you.
Thank you. Chandrayaan 3's success on the lunar South Pole has positioned India to the billions of dollars in profit because of the lunar economy in the coming decades, as it will be the first successful step for India. Gaining a foothold of the moon also carries a great significance.
Isn't that wonderful to hear? Over to you, Shobit.
Thank you, ma'am. So the success of Chandrayaan's mission has had a positive impact on India's geopolitical position in the global space community and its collaboration with other countries in several ways. Like point number one, first, international recognition. The successful Chandrayaan missions have garnered international recognition and respect for India's space capabilities. They demonstrated that India could design, build, and operate complex missions on the moon, showcasing the country's technological prowess on a global stage. Point number 2, enhanced collaboration. India's achievements with the Chandrayaan missions have encouraged greater collaborations with other space agencies and organizations. It's happy to note that ISRO has engaged in joint lunar explorations with agencies like NASA, Roscosmos, leading to data sharing agreements and collaborative lunar research projects. Point number 3, the capacity building. The Chandrayaan missions have boosted India's space industry and its capacity to offer space-related services, including satellite launches to other countries. This strengthens India's position as a reliable space partner. Thank you.
Such wonderfully put, Shobit, in points. I really appreciate your response. Thank you so much. Yes, Nivan?
Yes, Miss. So I would just like to add on, Shobit. I would like to say that considering that India has managed to pull off such a flawless landing on the moon, little to no difficulties had ever been approached in doing so. I would like to say that this actually sparks a lot of reliability to other nations, that yes, India is a country that can not only offer cheap prices and is great to invest on, but can also successfully do so many missions with their ingenious scientists and engineers. And this will heavily improve collaboration and trust by other nations to India, and will allow for a higher budget to achieve even more amazing tasks by India and the rest of the world to support unity and to make humanity slowly but surely interplanetary.
Absolutely. I totally agree with you. The landing seemed like a truly soft landing. There were no hiccups. It just landed. And yes, we should share the resources. We will share the resources and will definitely collaborate with other countries for greater good. Over to you, Shriyant.
The success of the Chandrayaan's mission has significantly bolstered India's geopolitical position in the global space community. For example, global recognition. The successful landing of Chandrayaan-3 on the moon's south pole marked India as the fourth nation to ever soft land on the lunar surface. Geopolitical significance. The successful landing near the South Pole, a region of key scientific and strategic interest, positions India to potentially reap significant benefits from the lunar economy. This achievement carries great geopolitical significances.
Absolutely correct. Well put. Over to you, Inam.
To add on to all of this, it also showcases India's ability to actually get such high complexity missions with a low budget, because the missions that came before this were the ones done by America, Russia, and China. All of them had like a significantly higher budget, up to 10 times the budget that we used. And to top it all off, US and Russia took more than 15 attempts to actually land a soft landing, while we did it on a second try with a smaller budget. So this also showcases to the other organizations that with a higher budget, there's so much more that we can do with the current technology.
Exactly. I will definitely agree with you. We have shown the entire world that what can be done with a tight budget also. It's not always about the money. It's about the technology. It's about the method. Let's hear it from Vikrant.
Thank you, ma'am. The launch of Chandrayaan-3 and its predecessors created a worldwide dome of appreciation in India, now being viewed as one of the major superpowers of the world. Also, in 2024, NASA and ISRO are working together to create a dual-frequency synthetic aperture radar satellite to be used for remote sensing. It is notable for being the first dual-band radar imaging satellite. It is called NISAR.
That was a great information, Vikrant. Yes, it's about communication, remote sensing. And if you have watched yesterday's live telecast, data were being sent across from a different center to that mission operation center, and how everybody collaborated together, to make this entire thing possible. Let's hear it from Ditya.
I would like to add to all of the awesome responses given by the other panelists. So, this awesome achievement of us having a soft landing and also on such a low budget, and the other point that we are the first country to approximately land on Moon's South Pole, proves that our country, India, could also be in a race with the powerful countries in achieving milestones like this.
Absolutely. And I think the definition of power is going to shift a little. So it's not just about money or economy, right? All right. Over to you, Ms. Risha, for the next segment.
Different areas which are open and the ways these missions have put India at such a high state of in the geopolitical world. It's truly commendable. Going on to our next aspect, we've been talking about going green and savings and preventing the contamination and all. So coming up to the next aspect of our questions around what are the ethical considerations that ISRO takes into account when planning lunar missions, particularly in terms of preserving the moon's natural state and preventing the contamination. In short, how green is the mission? Rohit.
Thank you, ma'am. So, to answer this question, ISRO, like other space agencies, takes several ethical considerations into account when planning for lunar missions, with a focus on preserving the moon's natural state and preventing contamination. While space missions inevitably have an environmental impact, efforts are made to minimize this impact and conduct missions responsibly. Here are some of the key ethical considerations. Point number 1, planetary protection. ISRO adheres to planetary protection guidelines established by international space organizations. These guidelines aim to prevent contamination of celestial bodies like the moon with Earth-based microorganisms. Special care is taken to ensure that landers and rovers do not carry any kind of terrestrial life to the moon. Point number 2, non-interference with scientific sites. Lunar missions are planned to avoid landing or operating near historically significant lunar sites, such as Apollo landing sites. This preserves these sites for scientific research and historical purposes. So in terms of how green the lunar missions are, it's essential to acknowledge that space missions do require significant energy and resources. However, space agencies are increasingly focused on making missions more energy efficient and environmental friendly by using cleaner propulsion systems, reducing waste, and optimizing mission planning. While lunar missions may have an impact, they are designed with ethical and environmental considerations in mind to minimize their footprint. Thank you.
Wonderfully put across, Rohit. Bhavdeepti?
Yes, ma'am. Thank you. ISRO prioritizes ethical considerations by aiming to preserve the moon's natural state and prevent contamination during lunar missions. This commitment to environmental responsibility ensures that lunar missions maintain a green approach, minimizing the impact on the moon's pristine environment.
Great. Thank you so much. I'll move on to Casey now to add to this.
So see ISRO's planning, there are many parameters that were taken account to preserve and prevent moon's natural state. The first one that I really found was the site of where the moon, where the lander is actually going to land. They had to find a site where actually it would not cause any harm to the moon's surface. And the planning sites were actually having minimal impact. Some other examples from Chandrayaan 1 and 2, the first lunar mission what happened was they first had this orbiter which orbited around the moon's surface, and again we see that it did not have any biological contamination. Then Chandrayaan 2, then we had this Vikram lander and rover, and the rover was designed very specifically to land on the site without altering any of the lunar's environment. So while it was roving, it didn't actually disturb any of the lunar surface. And I think one last point was they are very energy efficient missions planned. The Chandrayaan mission, I mean, was planned so energy efficiently wise. They had these neatly planned design for the spacecraft, which would use all the energy very wisely and made it like, again, cost efficient and consuming less fuel, which was a commendable job.
Truly, absolutely agree with this. Vikrant.
Thank you, ma'am. So, ISRO takes measures not to disturb the natural elements of the moon. The preservation of the moon's natural state is by doing a soft landing, as in slowly descending onto the moon's surface and using fuel in such a way that the moon's atmosphere doesn't get contaminated by the greenhouse gases emitted by the thruster on the payload.
Beautifully put, Vikrant. Priyan?
Yes, ma'am. I would like to add on that ISRO, like other space stations, follow a set of guidelines produced by United Nations Office for Outer Space Affairs, or also known as UNOOSA, and Committee on Space Research. So they follow these set of guidelines produced by UNOOSA and COSPAR to prevent contamination of the moon and other celestial bodies.
So scientific exploration and trying to do a lot of experiments over there is one aspect, but at the same time, not disturbing the natural state of these our natural satellite is also of a prime concern for us, and we take ISRO takes a great care in that, and I'm so happy to hear all your answers. That how wonderfully that you put across these points. Over to you, Ms. Sangeeta, now for next.
Thank you, Miss.
question.
I totally agree with you. How well the participants have thought about all these matters, and they're putting all their feelings and thoughts forward. Now, moving to the next question, let's talk about us. So my question will be, can you shed light on the role of Chandrayaan missions in inspiring and engaging the younger generation in STEM fields like you? Bhavadipti.
Thank you, ma'am. The Chandrayaan missions have played a pivotal role in inspiring and engaging the younger generation in STEM fields. These missions capture the imagination of students and aspiring scientists by showcasing India's technological achievements on a global stage. The success stories of Chandrayaan missions serve as powerful examples of what can be accomplished through scientific inquiry, innovation, and teamwork. This inspires young minds to pursue careers in science, technology, engineering, and mathematics, contributing to the growth of India's future workforce and its position in the global scientific community.
I totally agree with you, Bhavadipti. We must always keep dreaming, and no dream can be very small to achieve, right? Let's hear it from Vikrant.
Thank you, ma'am. So, the missions intrigue children by giving them a peek at information about the technological world through the broadcast, and especially to mention the movie adaptations of the missions. Like, for example, Mission Mangal for Mangalyaan. There are subliminal messages in there telling young children that you should reach for your dreams, because following your goals and keeping an open mind will lead to success, even if there are difficulties too, because there is always scope for improvement and nothing is impossible.
I like how you ended it. Nothing is impossible. Exactly. Over to you, Shobhit.
Thank you, ma'am. To add to the fellow panelists' points, I would like to add a few points. So, first point, role models. The scientists and engineers who are involved in the Chandrayaan missions serve as role models for aspiring STEM field students. So their success stories and dedication to their work motivate these young people to pursue STEM careers. So, and to add the second point, increased interest in space science. So the Chandrayaan missions have sparked greater interest in in space, in space science among students. They have led to an increased number of students choosing space-related subjects for higher education, to name just a few. Thank you.
Thank you, Shobit. Let's move on to the last question. We are really short of time now. Requesting Ms. Lisha to go to the last question, please.
So difficult to end it. We are, and 1 hour we discussed, and it was such an engaging discussion over here that it didn't even seem that long. So coming to our concluding question, where we are going to look into the future. How do you envision the ISRO's role in shaping up the international space exploration efforts, and what might be the focus of the upcoming lunar missions? Well, we have so many raised hands. Okay, moving on to Nivan.
Okay, Miss. Thank you. I would like to say that though ISRO hasn't planned any missions to the moon just yet, they're kind of focusing on the sun and Venus right now. I could say that ISRO's might actually be having some plans for permanent settlements on the moon by a lunar basis. There's a lot of things that we've already talked about earlier it's me and our amazing other panelists. And we've covered that a lot of the main objectives of Chandrayaan-3, 8, 2, and even 1 have actually seemed to be laying the foundation for the dream of India making their own lunar base. And that really promotes to make humanity interplanetary. Because as someone had already mentioned, and rightfully so, sending rockets from the moon is much easier to do so than on Earth because of a much lower gravity and no air resistance.
Wonderful. Moving on to our next, Himesh.
ISRO will play a vital role in the international space exploration by leading technological advancements in fostering global collaborations. The focus on upcoming lunar missions might be on exploring lunar surfaces for potential resources, studying its geology, and possibly for searching life on Moon.
Wonderful. Inam, would you like to add to this, my dear?
Similar to the other points people already said, the moon exploration already provides a base for how we can go to the moon again. And hence this would help in future missions such as going to Mars, which is currently a very hot topic in the space industry right now. Like Elon Musk and all are trying to do that, and we might be able to achieve that as well because of the moon settlements. And yeah, the already existing infrastructure allows us to build more missions on a lower budget.
Yes, that's true. That brings us to the conclusion of today's panel discussion. So we conclude the session by thanking all of our members of the panel for bringing such excellent insights into the questions that were raised. We wholeheartedly thank the audience for joining and the school management for arranging the event to commemorate the groundbreaking success of Chandrayaan mission. Let us not forget, this is the first step, and there will be many, many more. And we hope to get the opportunity having such engaging discussions once again. Thank you. Jai Hind.
Thank you everyone for joining. Let's disperse for the classes. Namaskar and Jai Hind.